In this video, I'm going to show you how to do homework for the profile leveling. Now, over on the left-hand side is the instructions. It says, prepare a set of profile leveling notes for the data listed and show the page check. All data is given in feet. The elevation at benchmark A is 1364.58, and the elevation of benchmark B is 1349.26. We're actually starting at one location and ending in another. That means when we do our page check and our closure, we're checking to see if it ties back into benchmark B. The ROD readings are plus S, meaning the plus S means our back site, and our IFS is our intermediate foresights. The negative S, or the minus S, is going to be our foresight readings. So the ROD readings are, the back site on benchmark A is 2.86, that's written here. And the intermediate, and that should say foresight, the IFS on 11, station 11 plus 00, is 3.7. Now the back site, the minus site, which is our foresight on turning point 1, is 10.56. And the back site on turning point 1 is 11.02. The intermediate foresights on 12 plus 00, 12 plus 50, and 13 are 8.77, 6.5, 5.7, and 6.3, all respectively. Now, we'll have a minus foresight on turning point 2 of 9.15 and a back site or a plus site on turning point 2 of 4.28. Now the intermediate foresights on stations 14 plus 73, excuse me, 15 plus 00, 16 plus 00 are 3.5, 4.2, and 6.4 respectively. We have a foresight, a minus site on turning point 3 of 8.77 and a back site on turning point 3 of 4.6. The last final foresight, true foresight, to benchmark B is 9.08. So what we have is we've got this information set up in an Excel sheet. So I want to show you the first thing that we're going to do. The first thing that we're going to do is we're going to calculate our instrument height. Remember, elevation plus back site gives us HI. So I'm going to write 1364.58 plus 2.86. That's going to give us an elevation of 1367.44. Now, we don't do anything with the intermediate foresights just yet. So I'm going to go ahead and calculate my elevation at the turning point 1. So we're going to say it is the HI, and I'll write the numbers out, 1367.44 minus 10.56. Okay, so that is the elevation on turning point 1. Now we're going to take the elevation at turning point 1 and we're going to add the back site. So that's going to give us the HI. So equals 1356.88 plus 11.02. Let me fix that. There is a strike through on that for some reason. Superscript. Okay, so the elevation here at our HI is 1367.90. So I'm going to take the elevation there, and I am going to figure out what, I'm going to take the HI, subtract the foresight, and I'm going to get the elevation. Equals 1367.9 minus 9.15. That's going to give an elevation at turning point 2 of 1358.75. Now, I'm going to take that elevation plus the back site, and that's going to give me the HI, equals 1358.75 plus 4.28. So that's going to give me an elevation of the instrument at our third setup. Now, I'm going to take this and our true foresight, and I'm going to get the elevation at turning point 3. So HI is 1363.03 minus the foresight of 8.77, and that, oops, I got to put an equal sign in front of it in Excel, and that's going to give me 1354.26. Okay, so remember, elevation plus back site gives me HI. 1354.26 equals 1354.26 plus 4.16 is going to equal 1358.42. Now, this is where we check in and calculate the elevation at benchmark B. So we're going to take 1 equals 1358.42 minus 9.08. That's going to give us 1349.34. Now, remember what I said. The elevation of benchmark B that we have to tie into is 1349.26. Now, these two don't match. So we know that there is an error. Either it's misclosure or we did a bad page calculation. So let's go ahead and add up. So we're going to say equals 2.86 plus 11.02 plus 4.28 plus 4.16. That's going to give us 2232. Now I'm going to add up my 4 sites. So I'm going to say the 10.56 plus 9.15 plus 8.77 gives me, oops, I left one out, 8.77 plus 9.08 gives me 3756. So I'm going to go ahead and push this down. And here's how it looks. We know that the beginning is 1364.58. We're going to add our back sites, and that's going to equal 1368.9. Okay? So 13.689 minus 37.56 gives us 1349.34. So it does check. All right? So on this, let me write these like this. So when I add these two and I get the 1386.90 and I subtract the 3756, we confirm that what we calculated is true. That means we have a misclosure. So our misclosure says it's the true elevation, the 1349.26 minus the calculated, the 1349.34, and it gives us a misclosure of a negative 0.08. That means that the true value is actually lower than what we calculated. So we have to do corrections. The corrections also we're going to do is on our HI. Our permissible misclosure is how many setups do we have? We have 1, 2, 3, 4 setups. So our number of setups, so we're going to take 0.02 times the square root number of our setups. The permissible was 0.04. Now, we actually would have to go back out into the field because we are over that error. But we're going to go ahead and move on and do adjustments. Now, the instrument height adjustment, and I'll show you how to do the calculations. So basically what we're saying is going to be the instrument height of 1367.44 plus, minus 0.08 times 1 over 4. Not 74, 1/4. Okay? Oops. So what that did, if you look up here in that equation, what it allows me is the multiplication of 1/4 of the error and subtract. I'll do it again. So this elevation, instrument height elevation, is 130, or the height of the instrument is equal 1367.9 minus 0.08 times, that's what Excel was trying to tell me. I put in parentheses 2 over 4. Okay? So that's the second, it's proportional. Okay? Now, the third one is the 1363.03, so equals 1363.03 minus 0.08. And again, it's 0.08 because the misclosure, not the permissible misclosure, but the actual misclosure between the true value and the calculated value, times, and that little symbol right there is multiplication in Excel, 3 over 4, because this is the third setup. And lastly, it's going to be equal, and the last HI was 1358.42 minus 0.08 times 4 over 4. Okay? So this is just, I wanted to show you how I got these values. Now what we're going to have to do is we are going to have to cross that out and write a new value. So I'm going to do this in Excel this way. So I'm going to go and I'm going to do a strike through on each one of these. Because we know that that's not the HI that we need to use. So this is kind of like doing it in the field, but I'm doing it in Excel. Kind of make it a little bit neater than my own handwriting. Oops, wrong one. All right, so now my new HIs are 1367.42, 1367.86, 1362.97, 1358.34, and we're going to use those to get adjusted elevations. So on this one, we're going to go equals 1367.42 minus the IFS of 3.7. So the elevation at that station is 1363.72. And then we're going to do it again. Now, this HI is used for this true foresight. So don't get confused about how this is being labeled. I just can't get Excel to put it on the same line. So I'm going to say 1367.42 minus 10.56. I got to put an equal sign in front of that. Okay? Now, this next set, so maybe I should turn, let me do this. We'll say that one is the green, and we'll do purple. Okay? So these will be purple also, just so you'll see the difference. 13 equals 1367.86 minus 8.7. 1367.86, we're going back to the HI here, minus 6.5. I keep forgetting to put my equal sign in front of it. In Excel, we always use formulas, and a formula always starts with an equal sign. 1367.86 minus 5.7, and then equals 1367.86 minus 6.3. All right, now in the next set, oh, I've got one more. So 1367.86 minus our true foresight, 9.15. Okay, now in this, did I type that right? So we have these values, these, except for the very first one, the rest of these values would be incorrect. They should have a strike through also. Okay, so all those values are incorrect. Now, on the next set, these sets, I'm going to go ahead and change that to a orange. So this will be orange also. So now I'm going to use 1362.97 minus 3.5. Oops, equal sign. Ugh. So that's 1359.47. All right. Now, in the next one, I've got 1362.97 minus 4.2. Put my equal sign in there. And the next one is 1362.97 minus 6.4. And lastly, equals 1362.97 minus 8.77. All right, so that's what the values are for these. Now, the last set, I'll go ahead and leave as, I'll make that red just to be the same. So this one is going to be equals 1358.34 minus 9.08. So this value matches what our true value was supposed to be as we stated before. So all of these would be our adjusted elevations. Now, let's go back to what the homework said. So now what we've got is we've got our elevations selected. The next part says, plot the profile in the previous problem and design a grade between stations 11 plus 00 and 16 plus 00 that balances the cut and fill areas. What that means is I'm going to create a profile of just the stations, not the benchmarks or the turning points, just the stations with their adjusted elevation. So let me show you that. So what I've done is I've taken the stations here and I've taken the elevations next to it and I've plotted them on a profile. So I could change this chart and say this is the profile leveling of that center line. So I only used the stations and its elevations to draw this. So the very first one is station 11 is plotted up at 1363. Station 12 plus 0 is 1359.16. Station 12 plus 50 is 13 and so forth. So the ground, this is what the ground looks like at those stations. Now, the next part of the question says, create a center line that allows you to do the cut and fill balances. Basically what that means is I would have to create some type of line in here. Let me do that differently. That allows me, oops, come back up here and I'll have to clean it up in a second. I need to create some type of profile in here that balances the cut and fill. So I'm just going to do a straight line to make my life a little bit easier. Let's say I have to tie into the natural ground and I had to tie it back in to natural ground. I'm going to change that to red and I'm just going to make it a bit wider. Okay, so that means this area here, let me see if I can draw it. That means this area here, whoops, I'm having a hard time using Excel. And I'm going to fill this. And I'm going to do green. Send to the back. So that means what I've shown you in green is the area that needs to be cut or that needs to actually be filled. Okay? If the natural ground is blue and the red is a proposed grade line, then I need to fill the green area. Okay? Green is fill. Now, if I drew, go back here, this, and I did a solid fill of orange, the orange area would be my actual cut area. So I need to cut all the dirt out because remember, the blue line, and I'll make that a dark blue so you can see it a little bit easier. That blue line, and I'll make it a bit thicker, is what natural ground is. The red line, and I'll bring that to the front, is what we propose the grade to be. So I have to cut this dirt out here and I have to move it to this yellow area here. Now, does that make it balanced? No, because I'm going to actually need more dirt on this side to, I would have excess cut. That means I think I would actually have to take away some dirt, haul it off, truck it, whatever. We usually want a balanced cut fill is because it costs money to haul away dirt and it costs money to bring dirt in. Not only is it trucking charge, but it's handling fees of the dirt, whether you're purchasing it or sending it somewhere else. Now, the last part of the project says, what is the percent grades between the stations 11 plus 00 and 12 plus 0s? So I want I want percent slopes on each one of these segments. And I'll show you how to do that. So what I've done here is I've set up the station and adjusted elevations in a table format. And I've listed the distance between the stations. That means what's the difference between these two stations. And I've also listed the change of elevation between two stations. So I'm going to write 1200 minus 1100. That's the distance between the two is 100 feet. Now the change in elevation, 1359.16 minus 1363.72, is the elevation. There is a drop, so it's negative. So the slope is going to be the rise over the run, minus 4.56 divided by 100. That is in foot per foot. Now, if I wanted it in percent, I would take that value and I would multiply it by 100. Okay? So it's 4.56%. Now, I want to note that it's negative, so I know I'm going downhill. So the next one would be 1250 minus 1200, and it would be 1 equals 1361.36 minus 1359.16. These two values. Now I'm going back uphill. So you can see it's going uphill from this point to this point. So it's 2.2 divided by 50, which I'm going to take that 0.04 and multiply by 100. Now in Excel, all I'm doing, if you've noticed, is I'm just using that cell value. I can type it in, and that's what I'll do in the next one. So the next one's 1300 minus 1250. That gives me 50 feet between those two. And the value is 1362.16 minus 1361.36. So it's still going uphill. So I'm going to take 0.8 divided by 50. So I can say equals 0.016 times 100. So it's 1.6%. And I continue to do that with the rest of them. Oops. So now I'm going to show you in Excel how to do that too. I'm going to say equals this cell minus this cell. And then I'm going to say this cell divided by this cell. So this is how Excel does it. Equals this cell times 100. So I'm showing a little bit of how the Excel program works. Now, I have to actually type in the 1473 and the 1400 because these are text. It considers them text and not numbers, so I have to actually write those. But here's the other cool thing. So if I do this again, I could say, all right, since the adjusted values are numbers, I can say the 1359.47, 47 minus the 1361.56. So notice the color coding also, the blue and the red. So those are just formulas. So again, I've got a negative value, so I'm going downhill. The slope is going to be the change, the 2.09, divided by the 73. So it's a 0.02863 foot per foot slope. So I'm going to take that value and multiply it by 100 to get percent slope. Okay. Now, I can change these later into how many decimal places that I want. Usually I only go 2. So that's, another Excel trick. So on this one, I've got 15 minus 1473. Now here's another cool thing. You can just drag this down and it copies the formula. So 1358.77 minus the 1359 gives us the value change between elevations. Rise, 0.07 divided by the run, the 27 feet between it. And I'm going to take equals 0.059 times 100. So you can either type the values in or you can use Excel to do the math for you. And the last one is 16. Always use an equal sign. 1600 minus 1500. And then 1356.57 minus 1358.77. That gives us a negative value. Notice the rest of these have been negative because they're going downhill. So a minus equals a minus 2.2 divided by 100. And then that should have been a negative value right there. Sorry about that. So the next one is this multiplied, the slope in foot per foot multiplied by 100. Okay, so that gives me the slope for each one of these segments, and that's what you'll do for the homework. You'll give me a chart that has the percent slope in there. All right, that's it for this video.